If you're asked to solve this equation, the hint is to solve by factoring, because this is one type where you can solve by factoring by grouping. Put a group around the first parenthesis, the first two terms, and put a group around the last two terms, but make sure to take that negative sign with your group. And then factor out what you can from each group. This group has n squared that's in common, because n to the third can be afforded to be divided by an n squared, and n to the second can be divided by n squared. This next point is kind of a finer point that students sometimes miss. Just make sure when you're factoring by grouping, if you stick to making the leading term positive all the time, you'll always get it so your parentheses match. So in this second one, there's nothing I can factor out except for a 1. And I'm taking a negative 1 because that's going to change my sign to that first number to be positive. And the reason why I did that is because now I have two parentheses that match. So I can factor out one of those parentheses. That's a 3. And then I can make a new parentheses with the stuff on the outside. And now she's factored. Okay, but if you're not sure how that last step happened, you can remember it like this: when you have two parentheses that match, your final factored form will be one of the duplicated parentheses, and then that parentheses made of the stuff on the outside. And now we just need to solve each separate parentheses, because when it's factored, you just take each parentheses and set it equal to 0. So if n equaled 3, this parentheses would be 0, and we'd have our this whole left side would equal 0. If n equals 1, that would make this parentheses equal 0, but there's another one there, n equaling negative 1. Plug that guy in. Negative 1 squared gives you positive 1. 1 minus 1 makes 0. So these are your three solutions.